Hey, it's Dr. J back again with part 2 of the functions introduction, section 3.1. I could have gone on for another half an hour on the last part, but I figured we need a little break, come back and handle a whole different type of problem. In this section, we're going to be talking about writing function notation. We did a lot of examples of it last time, but I didn't show you how to actually create function notation from an equation or something like that. And then we're going to do some more evaluating. And then finally, what we call the catalog of functions. The catalog of functions is a well-known finite list of functions that we expect every college student to know. It certainly is not an exhaustive list. There are lots of functions outside the catalog, but in order to have a good understanding of the concept, we just stick to what we call the basic catalog, or some people call it the toolkit. It's another name for the catalog. I like to call it a catalog, but some people call it the toolkit. Okay. So we're going to start off with writing function notation. All right. This is relatively straightforward. It's taking an equation and writing it as a function. We'll start off with linear equations, and we'll go through a couple different examples. And most of this you'll see sort of as we move through chapter 3. I'll keep throwing out different types of functions, but I just want to kind of give you the basic idea of how to write something as a function of x. All right. So when I say express this equation as a function of x, what am I basically saying? I'm basically saying solve for y, then replace with f of x. Because remember, in our minds, function notation is y is f of x. And remember, we say y is a function of x. All right, without any further ado, let's just go ahead and do it. So you're going to solve this equation for y. Let me just rewrite it here. You're going to subtract 4x from both sides. So you're going to get 6y equals negative 4x plus 12. Remember, this looks like 12 minus 4x, but you're actually adding positive 12 and negative 4. And I like to write it in this order with the x first. Okay, it's like slope form, slope-intercept form. Divide everybody by 6 and simplify this if possible. Negative 4/6 reduces to negative 2/3, and positive 12/6 reduces to positive 2. Then we're going to replace the y with f of x. And so the answer, if I can squeeze it over here, f of x, that's our y, is negative 2/3 x plus 2. That's kind of hard to see. Let me write that a little bit bigger. Make sure you don't accidentally put the x in the denominator. So when you're typing it, make sure the x is either off to the side, or if you really want to be safe, you can put the x up top with the 2. I would also accept negative 2x over 3. That would also be correct. All right. Now, once you've rewritten it for this particular problem, we're done. But the idea is once you've rewritten it, now you have a function. Now you can evaluate it, you can solve it, you can graph it, and we'll do all of that in the coming sections. Okay. I just want to get you going with how to rewrite them. How about this one? I want you to express the function 14t squared minus 2s is equal to 8t plus 6 as a function of t. This is what I've been sort of alluding to over the last couple lectures, and I'll start doing this more often, where I basically am giving you an equation that looks like x and y, but I'm using different letters. In this case, I'm using s and t. So as a function of t, we mean solve for s. So you're treating s as if it were y, and you're treating t as if it were x, which I always thought was weird because it's reverse alphabetical, but that's just the way we do it, all right? So we're going to solve this equation for s. I want to get s by itself. Okay, so come on down here. Go ahead and just rewrite it. If the different variables annoy you, or you feel like you will write them sloppily and make a mistake with them, I always say that you're allowed to just rewrite it as x and y and then switch it when you're done. So your t's would be your x's and your s would be your y. I recommend this if you're sloppy, because sometimes s's will look like 5s, and then this will look like 25 or something, and then you're in big trouble, okay? Okay, so we want to solve this equation for s. We want to get s by itself. So I'm going to subtract 14t squared from both sides. Remember, you're adding. Even when it looks like you're subtracting, you're really adding. So that's plus 8t and then plus 6. Now here's the important part. I mean, it's all important, but here's the really important part. When you're dividing by a negative, you're going to change all of the signs. All of them. So this is going to become 7t squared, negative divided by a negative. This is going to become negative 4t, positive divided by a negative. And this is going to become negative 3, again, positive divided by a negative. This is your function. So we call that f of t. It is a function of t. In other words, t is the independent variable, so t is behaving like x, right? You probably remember from that word problem section we did, where I treat time like x. Yeah, t is for time. And there's another word problem section coming soon in chapter 3, but maybe soon is the wrong word, but eventually I'll have to do some word problems in chapter 3. That's all I have for this particular skill. I just wanted to give you the idea of how to rewrite an equation. Notice there's no function in the original problem, but you are then expressing it as a function. So now as we move through the sections 3.2, 3.3, 3.4, you might notice that this happens quite frequently, depending on the context of what we're doing. Okay, so in this particular lesson, it's done. For the rest of these problems, I want to talk about evaluating. Remember, evaluating is a fancy way of saying plug in the value. So for these examples, I'm going to give you the function and then just ask you to do some evaluations. And let's go back to our good old x variable. F of x is negative 6x plus 7. I'm going to ask you to do various evaluations. So let's do 3 parts. F of a plus h, f of a plus h minus f of a. So again, evaluate means plug in the value and simplify. You know, in math, we don't like to say plug in the value and simplify. I will never say that on a test. I will say evaluate. So I'm going to put this in a bubble. When you hear me say, or when you read evaluate, this is how you interpret that. Plug in the value and simplify. Okay. So the value that I'm plugging in is a. All right. You might think a doesn't look like a value, but it is. A is a value. It stands for any. A means any value. Yeah. So we're going to replace all of our x's with a. And that's it. It's already simplified. So I don't have anything to do in that part. That part's done. Sometimes this is referred to as a replacement value. I'm just swapping my x's for a's. Doesn't change the function in any way. It just changes the appearance of the function. It's been replaced. Okay. Part B is going to be a little bit tougher. I hope I have enough room for it. I am replacing my a, or in this case my x, with a plus h. If you like to remember what letters actually mean, a means any value. H stands for horizontal. So at some point when we're graphing this, you'll see maybe in 3.4, 3.3, I think it's 3.4, we start graphing these things. The H would be a horizontal, if you've seen this before. This is not already simplified. This needs to be simplified. So we have one step. That's to get rid of the parentheses. And so the answer is negative 6a. Be careful with the signs. Negative 6h. And then plus 7. Okay. Now the cool thing about this problem is once you've done part A and part B, you can combine them together to get part C. Although I probably shouldn't use a plus sign. I should probably just write the word combine. So this is part B. Negative 6a minus 6h plus 7. Minus part A. Make sure you use parentheses around part A. Part A was negative 6a plus 7. You need to be careful. And not only am I telling you to be careful, but I'm telling myself to be careful. That negative sign is going to distribute like an invisible negative 1. And I'm going to get negative 6a, negative 6h plus 7. This negative is going to distribute. Positive 6a, negative 7. Yeah, negative times a negative is a positive. Negative times a positive is a negative. And then I'm going to cancel 6a, negative and a positive. Those are going to cancel. 7, negative 7, positive and a negative. Those are going to cancel. And so my final answer is just negative 6h. And that's it. That's the simplified evaluation. Right. Here's one abstract way of thinking about it. These are the inputs, and this is the output. Yeah. Or these are the x's, the x values, and this is the y value. So you go back to thinking about how the inputs and the outputs are related to each other. That's it. Want to do another one? Same question. Same question. So we have 3 evaluations. This is our function that we're given. F of A, simple, right? Just replace all your x's with a's and smile. Easy does it. Yeah. Part B, not so easy. It takes a little bit more time. Replace all of your x's with a plus h. Be very careful with your writing. Use parentheses. Okay. You need to do the exponentials first. So do this first. That'll be a squared plus... Here, let me write it out. I'll come back to this part C in a second. Let me write it out. I don't want to lose anybody this early in the semester. I'm holding off on the +2 and the -7 for now. Just wait. First, I want to do this first. All right, remember the order of operations, parentheses, exponents, then you're going to multiply by 3. So this will be a squared, AH, HA, but HA is the same as AH, and then H squared. I might as well take care of these guys while I'm at it. -7A, -7H, and then +2. Just bring that down. Now you can distribute the 3. Combine any like terms. I guess I could have combined them earlier in the process, but I mean, as long as I do it at some point, it doesn't matter at what point I do it. So we're going to combine these guys. Notice they're both positive, so they do not cancel. I can't tell you how many times I've seen people cancel those out. And that's your answer for part B. Okay. Now, let's do part C. I had erased it temporarily. So part C, f of A plus h minus f of A. Well, that's just part B that we've already done, minus part A that we've already done. So we can just copy these, and then I'm going to have to erase all of this. So part B goes first. Then make sure you put parentheses around part A. All right, you must use parentheses because you are subtracting. All right. Sometimes it's neat to do this in your notes. I know it's not what you're going to put on the computer, but it's just what you're going to put in your notes. And that way when you put this in, you don't forget those parentheses. Anything that you can do to help you remember is going to help you eventually. So now I've got 3a squared plus 6ah plus 3h squared minus 7a minus 7h plus 2. Distribute that negative. So that's negative 3a squared, positive 7a, and negative 2. Be really careful with signs. And then look for like terms. 3a squared, negative 3a squared. Those are going to cancel. 7a and negative 7a, sorry, negative 7a and positive 7a. Those are going to cancel. Positive 2 and negative 2. Those are going to cancel. So your final answer is 6AH plus 3H squared minus 7H. That's your final answer for part C. All right. So that's called abstract evaluations. An abstract evaluation is where you're plugging in something that's not an actual finite number. It's an arbitrary number. This might look like another equation, but this is a number. This is a value, and we'll learn about what this value means in the coming sections. This chapter is taken in an approach where I show you stuff intentionally not explaining everything right now because we're not quite ready for it yet. I just want you to have the skills. So you learn the skills first, and then you learn the reasoning later. All right. It's totally opposite of the way they did things in the 90s. Back in the 1990s, they had this idea that they could teach you the idea without teaching you the skills. So this philosophy was, oh, the skills will come later. The ideas should come first. We've now decided that didn't work out so well. All right, we ended up with an entire generation of students that didn't have any skills because they were learning the ideas before the skills. So now the approach has changed. Teach you the skills first, and the ideas will come later. Example 5. All right. So given f of x is equal to negative x squared plus 5x minus 4, evaluate f of a plus h minus f of a, all divided by h. This has a fancy name that we'll learn in the future. I think it's 3.3. It's called the difference quotient. I'm not going to write that down right now, but it's difference, subtraction, quotient, fraction. Another name for this is the subtraction fraction. The difference quotient, subtraction fraction. Okay. In 3.3, I'm going to make you learn that, so might as well just show you the skill now. All right. Let's do this in steps. Step 1, f of a. That's the easy step. Negative a squared plus 5a minus 4. Done. Step 1's easy. Step 2, f of a plus h. All right. This one's a little tougher. Negative, parentheses, a plus h squared plus 5, a plus h minus 4. Now, step 2 takes a little work. Step 1 is always quick. Step 2 takes a little longer. Make sure you wait on this negative sign. All right, wait. If you put that negative sign in now, you will get the wrong answer every time. Every single time it'll be wrong. So do it the long way. A squared plus AH plus AH plus h squared. All right, I'm not doing that again. We just did it in example 4. Okay. Maybe I'll do it a little bit differently this time for those of you that are saying, Dr. Jordan, why don't you do that first? You can combine these first. And I would say if you're already expert in algebra, if you're already an expert, you got an A in your previous algebra class, you can just jump right to here if possible. In other words, you can skip this whole step if you're really good. Yeah? So jump if you can. Yeah? You never know what you can do until you do it. Yeah, and you go, oh, I didn't think I could do that, but you can. Yeah. And then now distribute the negative at the very end. So negative a squared minus 2ah minus h squared plus 5a plus 5h minus 4. So that's the end of step 2. Step 3, combine steps 1 and 2 using this recipe that we just did. The only thing different is now this has a divisor. The last example 4 did not have a divisor, but example 5 has a divisor. My board's not quite big enough to do all of this, so here's what I'm going to do. I'm going to go like this. I'm going to write step 1 answer, negative a squared plus 5a minus 4. Step 2 answer. All I care about is the boxed part. Negative a squared minus 2ah minus h squared plus 5a plus 5h minus 4. You probably can't see that. There's a minus 4 right there that I couldn't quite fit. So the last step now, I'm going to evaluate this difference quotient. F of a plus h, that's step 2. I do step 2 first. So negative a squared minus 2ah minus h squared plus 5a plus 5h minus 4. So that's all of step 2. And then step 1 goes in parentheses. So step 1 goes over here. Negative a squared plus 5a minus 4. And then I'm going to divide all of this by h. This is the step that I did not have in example 4. Distribute the negative sign. And combine all the like terms. All right. So you've got a squared negative, a squared positive. Those are going to cancel. 5a positive, 5a negative. Those are going to cancel. 4 is negative, 4 is positive. Those are going to cancel. So now you have negative 2ah minus h squared plus 5h all over h. Now the last step, very, very carefully, remove one of the h's. Okay, look, everybody has an h. H squared actually means HH. So when you pull out an h, you're then going to cancel the denominator. You have an h in the denominator, you have an h in the numerator, and your final answer, if I can squeeze it over here in this little piece, negative 2a minus h plus 5. Here, let me write it a little bit bigger. Negative 2a minus h plus 5. That's your final answer. This is called the difference quotient. More on this in section 3.3. Okay. I'm done for now with this type of problem. Okay, this is a relatively short follow-up to 3.1, so I'm going to end today's lesson with what we call the catalog of functions. These are sometimes called basic functions. Some people call them parent functions. I like to call them mother functions. That's what I call them. This is also called the toolkit. You know, if you take enough math, you take many years of math, it starts to become like a language. In fact, it already is a language with lots of different words that are all interchangeably used, you know, just like any other language. You don't just want to say one thing. You want to have 20 things that all mean the same thing. I like to call them mother functions. All right. These are functions that you basically have to memorize. All right. You want to memorize the equation, the function form, the name, the table. I'll fill out the table in a second. And finally, the graph. I'm going to use the graph board. All right. So let's go through all of the toolkit or all of the catalog of mother functions. The first one, y equals x. Yeah? Y equals x is the equation. The function is f of x equals x. Notice the only difference? Y has been replaced with f of x. That's it. Y is f of x. In other words, y is a function of x. This is the simplest one, okay? Its name is the identity function. It is also called the linear function. It really depends on how you like to remember it. I remember identical. Yeah. Other people memorize line or linea. Yeah. That helps us over here when we draw the graph. We know that the graph is going to be a line. So this equation, this function, has really two names. Some people call it the identity. Some people call it the linear function. Now the table, all right? I always use the same spread. -2, -1, 0, 1, and 2. And maybe I shouldn't say always. I should say almost always. I use the same spread of numbers, -2, -1, 0, 1, and 2. There are a few problems where that spread doesn't work very well, and so for those problems, I will change my spread. But if possible, I like to use that spread. All right? Now watch how this works. You don't get to pick your y's. All right? Y is called a dependent. All right? You only get to pick your x's. Once you've picked your x's, you put them into the function. The function then is what I call the dictator. The function dictates who the y's are going to be. Now for this one, it's very easy because look at the equation. Y is identical to x. Right? That's what equals means, identical. So y is a function of x. So that means y is exactly the same as x in this case. If you plug in -2, you get out -2. And so when I draw the graph, now just to make the graph a little bit easier to see, I'm going to blow up my scale a little bit. So that you can see a little bit easier. Okay, so on the graphing board, I'm going to plot -2 and -2, -1 and -1, 0 and 0, 1 and 1. I'm just plotting all these points from the table. And then 2 and 2. And there you go. That's your first function. Yeah, it's called the identity function or the linear function. So I want you to know the equation, the function, the name, the table, and the graph. You need to know all of that. I'll give you a hint. Memorize one of these, and the rest of them are free. Some people literally try to memorize every single one of these, and you're just going to get confused. Just pick whichever one's the best. I like this one. Once you memorize that, the rest of it will all come from the thing that you memorized. Yeah. I hope that you're all using that trick, not just in math, but in other subjects as well. Somebody gives you 5 things that are all interrelated with each other. You don't memorize all 5, you memorize 1. Sometimes 2, and you use those to sort of unravel. I call that planting the seed. You don't memorize the whole tree, you just memorize the seed. And then once you have the seed, you can easily generate the rest of the information from that seed. Trying to memorize everything is futile. You'll just get confused and never learn anything. Okay, that's the first one. The next one is called y equals absolute value of x, or f of x equals absolute value of x. The name, absolute value function. The word function is implied. These are all functions. Yeah. All right. The table, we'll fill this out in a second. Leave it blank for now. It's typically 5 rows. Fill it out in a second. And then the graph on the board. Or in your case, on the screen. If we were meeting in a classroom, I'd be handing out graph paper, and you'd all be drawing these on your own graph paper. Well, not your own, but I guess you could have your own if you want. Anybody that has their own graph paper, feel free to use it. I don't require it, but it comes in handy. All right, so here we go. Absolute value. So the equation, y equals absolute value of x. The function, f of x equals absolute value of x. I don't have to say this many more times, do I? F of x and y are replaced. Yeah, y is f of x. I hope the name is obvious. Right? It's called the absolute value function because it has the absolute value bars. Make sure you make the bars look vertical and not look like the number 1. Otherwise, it ends up looking like 11 or something like that. We start with the typical spread, -2, -1, 0, 1, and 2. I will tell you when this spread is no good, and we'll find out why it's no good together. Maybe I'll make that a little bit easier to see. Hold on, let me just make my table a little bit bigger. Now this one you should actually do a little bit of math. And when I say a little bit of math, I literally mean a little bit of math, okay? We're going to plug these x's to get the y. So what is y? Y is the absolute value of x. So we're going to do y is the absolute value of -2. I'm just going to do these one at a time. That's +2. Yeah. I don't care which one you use. The function and the equation are synonyms. They do the same thing. They mean the same thing. They produce the same result. Tomato, tomato. So you could also use f if you like. Let's do that for the next one. -1. Absolute value of -1. That's +1. All right. You could do the rest of these in your head. What's the absolute value of 0? 0. What's the absolute value of 1? So I'm just going to say etc., etc. 1, and then the absolute value of 2 is 2. My general rule is, if it's a negative, actually do the math to make sure you're not screwing it up. If it's a positive, you have a brain, right? You've been doing this since you were 10, maybe 12 years old. You can do it. You can do it. You can do more than you ever thought you could do. You're better at this than you might think you are. All right, take this table of values and on the graphing board or on the screen, draw this graph. So I've got -2 and +2. That's up here, quadrant 2. -1, +1. 0, 0. 1, 1, and 2, 2. It should look like the letter V. Very sharp, not curvy and smooth. It's very sharp like the letter V. That's your next function. Keep track. Make yourself a catalog, and then you can use it on the test, right? Look at the catalog when you need to solve that type of problem. Or the homework, or the quiz, or the lab, or whatever it is you're doing. Yeah. Ready for the next one? All right, the next one, y equals x squared, or f of x equals x squared. The name, this one's a little tricky. It's not called the square function. It's called the quadratic function. Remember, quad means square. Out in front of the library, there's this area called the quad. I don't know if anybody calls it that anymore, but there's the quad. Often schools have a quad, or a business might have a quad. It's that square or rectangular. It's usually square, but sometimes it's more like a rectangle. It turns out that even a square is a type of rectangle, but we just call it a square, quadrilateral. Right? So its name is quadratic. I'm using the same spread. -2, -1, 0, 1, and 2. All right? Don't memorize the y's, unless you really want to. I don't memorize the y's. I just memorize the x's. Why? Because if you know the x's, you plug them into here, and that will tell you what the y's are, or you plug them into here. It doesn't matter. These are the same thing. I'm getting too sloppy over here. So, all right? So you don't have to memorize x and y. Just memorize x, and then use the function to give you the y's. Let's do a couple of these. So y equals -2 squared, which equals 4. Y equals -1 squared, which equals 1. All right, etc., etc., etc. I think you can do most of these in your head. All right, I'm never going to give you any crazy numbers that you can't calculate in your head. So 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. Okay, if you want to memorize them all, you certainly can. Some people do. All right, here's my graphing board. -2 and 4. -1 and -1. 0, 0. 1, 1. I'm just reading them off this list here. And 2, 4. Now this one is smooth, like the letter U. Look at the letter U, quadratic. It's smooth. As opposed to value, absolute value is the V. You gotta have a way of remembering which one's the V, which one's the U. There you go. That's your graph. Keep them coming. Keep them coming. Right down with the catalog. Keeping track. Identity, absolute value, quadratic. Let's keep going. Next one. All right, the next one. The square root, y is equal to the square root of x, or f of x is equal to the square root of x. Tomato, tomato. Now, in all of my career, when it comes to the language of mathematics, one of the most commonly mistaken words is square and square root. And so in the catalog, a square is called a quadratic. A square root is called a square root. And that makes it, it's supposed to make it a little easier to remember which one's which. So if you hear me say square root, I do not mean square. I mean square root. If I want to say this, I will say quadratic. Okay, that's not what I'm saying. I'm saying square root this time. All right. So here is one of the times where I have to change my table. Because notice what happens when I do negatives. Yeah. All right. There are no imaginaries in chapter 3. I don't know why. I really don't. I've been asking this question for years. Why do we teach imaginary numbers and then immediately take them away from you and say you can't use them? All right. They'll come back. They come back in chapter 5, but they're not coming back for a while. All right. So in chapter 3, anytime you get an imaginary number, pretend like you never took chapter 2 and just put DNE. Does not exist. Oh, I didn't do -2, but it's the same thing for -2. It's still an imaginary number. So I don't want you putting any imaginary numbers on. I guess if you really want to know why, I mean, I kind of know why. It's because they're difficult to graph. And this chapter is all about graphing. And so since imaginary numbers are not easy to graph in the real world, they live in a different dimension, essentially. They're, in the complex plane. We just pretend like we never learned them. All right, so just general principle, no imaginary in chapter 3. So if you get an imaginary, just put DNE. That's just an automatic does not exist. So that means I'm not going to use negative numbers. I'm going to start with 0. So the square root of 0 is 0. Then I'm going to do 1. The square root of 1 is 1. Okay. Now watch what I do next. I skip to 4. Why? Because it's perfect. So in my table, I only want to use numbers that are perfect because we're not using calculators. Right? I want an exact value. The only way to get an exact value is to pick perfect squares. So the next one, 9. And we can stop there. And stop at 9. Okay, so we're only going to graph this. We're not going to graph the DNEs. DNEs do not exist. That's what DNE means in this context. Since all my numbers are positive, you're going to see what my graphing board looks like. It's all in quadrant 1. So here's my graphing board. I only need quadrant 1. Yeah. So all in quadrant 1. I don't need any of the other quadrants. So 0, 0, right there at the origin. We call that the terminal point. The graph does not go past that point. 1, 1, right here. 4, 2, right here. 4, 2. And 9, 3. There's your graph. So this is the square root graph. The arrow goes only in one direction. There is no arrow at 0. That is a terminal point. It's as if the graph died, or you can think of it as being born at that point. Remember what a terminal is, like an airplane. Some people are getting on the plane. Well, other people are getting off the plane. So that's why we call it the terminal. For some people, it's the end. For other people, it's the beginning. That's what a terminal is. All right, you keep a track mentally? Yeah, what do we got? Identity, absolute value, quadratic, square root. We're halfway there. We're halfway there. By the way, all of these are in the book. So I'm literally going through the entire catalog. It's listed in the book. If you don't have the book, it's free. You can find it on the Canvas website. Just click on it or go to OpenStax and look for college algebra and OpenStax. So if you're scrambling to keep up with the notes, it's cool. Don't worry about it. I'm just showing you how I would do it in a normal lecture environment. This is the way I would do it on the board if I didn't have a book. I'm making the book for you. So the next one's called the cubic. X cubed. Some people say x to the third, but I think it's a little bit more college level English to say cubic. Yeah, I don't ever want to hear you say x3. You say x3 and I don't even think you're a college student. I'm like, what are you, in 5th grade? You don't say x3. You say x cubed or x to the 3rd if you really want to say that. This is called the cubic function. We're going back to our old table of values. -2, -1, 0, 1, and 2. That's our table. All right. Again, memorize the x's. This is a cubic. It's a lot like a quadratic. We're going to use the same x's. All right. Now, to get the y's, you can either memorize them or you can use the equations to generate them. Let's use the equation. Y is equal to -2 cubed. Or you could say f of x is equal to -2 cubed. I always think it's easier to just use the y. So y is equal to -2 times -2 times -2, which is -8. If you can do these all in your head, then you don't have to write all this stuff down. I'm just going to do a couple of them out. My general rule is do the negatives. -1 cubed. -1 times -1 times -1. That's -1. At this point, I'm just going to say etc., etc., etc. So 0. 0 times 0 times 0. That's 0. 1. 1 times 1 times 1. 1. 2. 2 times 2 times 2. 8. For this one, I like to put the graphing board vertically because the y values get very big. If I were to do the next one, it would be 3 times 3 times 3, which would be 27, which would be off this board. So the y values are much higher than the x values, so I like to stretch it out like this. So -2, -8, that's down here in quadrant 3. -2, -8. -1, -1, that's also in quadrant 3. 0, 0, that's the origin. 1, 1, and finally 2, 8. That is your cubic function. All right. Identity, absolute value, quadratic, square root, cubic. That's 5. It's a handful of functions. 3 more. 3 more. Hang in there. The next one's a BOGO. Buy one, get one. We're basically just going to turn the graph over this way. I'm going to leave this here for the next one because you're going to see how you can get the next one by remembering the previous one. The next one's called Cubert, also known as the cube root. In the 80s, back in the 1980s, when I was in high school, there was a video game called Cubert. Yeah? And so that reminds me of the name of this function, cube root. I know Cubert is spelled with a Q, but cube root, Cubert. say it really fast. Cubert. Yeah. This is the cube root. Yeah. It's like a square root, but it's cubed instead of squared. Yeah. So you're asking what number times itself 3 times, okay? And here's what you can do for the table. Just switch the 2's and the 8's. That's all you have to do. Switch the values from the x cubed table. All right. Notice you don't have to switch the 1's and the 0's because they're already identical. It's just the -2 and -8 and the +2 and +8. So you're going to get your table for free. All right, that's your BOGO. Buy one, get one free. For the board, what do? We just turn the board sideways. We just turn the board sideways. Now I do have to erase my old graph because I'm turning it sideways. This is now x, and this is now y. Exactly what we just did in the table. The x and the y have been switched. Yeah. All right, let's do it. -8, -2, that's down here in quadrant 3. -1, -1, that's also in quadrant 3. 0, 0, that's the origin. 1, 1, and 8, 2. It looks just like the cubic. It's just sideways. So that is your cube root function. Memorize cube, you get cube root for free, as long as you remember to switch. Yeah, the x and the y have been interchanged. More about this, I think it's in 3.7. At the very end of chapter 3, we're going to come back and talk about this one again. 2 more. You're keeping track. This is number 6. 2 more to go. All right. They're starting to get a little tougher now. The last 2 members of the catalog or members of the toolkit, are the reciprocal 1 over x. Some people call it the flip. Yeah, to flip x over is what reciprocal means. It's an easy way to remember what a reciprocal is. So if x is 2, you flip it over, it becomes 1/2. If x is 5, you flip it over, it becomes 1/5. The table is a little bit bigger in this one. It's got a lot of numbers. A lot of numbers in this one. It's 7 numbers. You don't have to memorize the y's, just memorize the x's. So you flip over x to get y. So to get the y value, you simply flip over the x value. So I'll do a couple of them for you. to get negative 2, you plug in negative 2, you flip it over, you get negative 0.5 or negative 1/2. If you use a calculator, it'll be a decimal, but I'm not using a calculator. It's negative 1/2. To flip over negative 1, you just get negative 1. 1 over negative 1 is just negative 1. Now here's where the flip over technique really works well. To get negative 1/2, when you flip it, you get negative 2 over 1, which is just negative 2. The next one's weird because you're plugging in 0. You cannot flip over 0. Yeah? The reciprocal of 0 does not exist. That's a DNE. Let's do the rest of them mentally. Flip over 1/2. You get 2. Flip over a 1. You get 1. Flip over a 2. You get 1/2. So now, to draw our graph, we're going to plot all of these points except this one, 0 and DNE. I'll explain that in a moment. Let's draw the points that we have first. Negative 2 and negative 1/2. That's right here. Notice I made negative 1 2 blocks so that negative 1/2 is 1 square on this graph paper. And then negative 1, and then negative 1/2 right there. That's halfway to negative 1, and then down negative 2. All right. This point here is not a point. It's called an asymptote. All right, we're going to graph them later in the chapter, so I'm just going to tell you the name of it, but I'm not going to actually do anything with it in this section. All right, so we just skip over it. We go to the next section. 1/2 and 2. So I got 1/2 and then 2 right there. 1 and 1 right there. 1 and 1. And then 2, comma, 1/2. That's right there. We're going to have an entire section in the future on asymptotes. So these are covered in chapter 5. All right. So in chapter 3, you just need to know the word. You don't actually need to know how to do anything with them. If you would like an intuitive explanation, it means that you cannot touch either axis. I mean, that's the best I can say right now until I give you a more detailed explanation. Okay. I know this has been a really long one. I know these are all long, but you know, if we were in class, this would be an hour and a half or hour and 20-minute long class. So we're almost done. The last one, it's called the reciprocal squared. I'm just going to keep all this the same. All right, so this is the last one. We're going to use exactly the same x's and y's. We're just going to do one thing to them. In order to get y, square these y's. In other words, square the y's that we just had. Now I don't have to do all of this over again. You can't square something that doesn't exist, so skip that one. Just square all of these. So you're getting another BOGO. If you memorize reciprocal, you get reciprocal squared. Flip over, and then to get y, square all the y's from the previous example. So these are your new y values for the reciprocal squared. And now I don't have to redo everything. Graphing 1/4 is very, very difficult. So what we're going to do is we're just going to approximate it. I'm not actually going to be able to get 1/4 on this graphing board here. You'll be happy to know that this is it. As soon as I graph this, we'll be done. Notice the x's are exactly the same x's they were in the last example. So this is the reciprocal squared. So this is my x, -2. This is my y, -1/4. I can't really get -1/4, so I'm just approximating. That says approximate, if you can see that there. This is approximate. Right. Approx. See that. So I got -2 and 1/4, -1 and 1. That one stays the same. -1/2 and 4. So -1/2 all the way up here at 4. And for the DNE, that just means do not touch 0. Do not touch the origin. Do not touch any of the axes. That's all I'm going to say about that. All right, so just skip this over. Skip. Jump over to the next one. 1/2 and 4 is way up here. 1/2 and 4. 1 and 1 right here. And our last point, 2. This is x is 2. And y is 1/4. Again, I'm just approximating 1/4. And that is your reciprocal squared. Notice there is nothing below the x-axis, the entire graph. Sometimes we call this the smokestack or the chimney because it looks kind of like a chimney going up on both sides. Okay, so you have 8 functions. You need to know the equation, the function, the name, the table, and the graph of all 8 functions, and that is your toolkit that we're going to be using for the rest of Chapter 3. Until next time, Dr. Jordan signing out. I'll see you on the internet.